Look in any mirror and you'd see a copy of yourself, right? Well, not quite. You'd actually be looking at your mirror image. It's identical to you, but the position of everything on your body would be reversed. At the molecular level, the differences between mirror image forms of molecules actually gives them handedness, just like people. Organic chemists use the term chirality to describe the handedness of mirror image molecules. A molecule is chiral if it is not superimposable over its mirror image. I'll demonstrate. These hand turkeys are mirror images of each other, reflected over a center line. No matter how I turn this turkey, I can never fit it perfectly over the other. They're chiral. Compare that with this pair of socks. They're mirror images, but if I turn one around and lay it over the other, they're the same. Molecules act the same way. A carbon atom is usually at the center of a chiral molecule because carbon can form 4 covalent bonds. Depending on the orientation of atoms around this central carbon, the forms are either left-handed or right-handed. By the way, chemists call a pair of chiral molecules enantiomers. Now that we know how molecules can have handedness, why is it important? Well, since biological molecules are built out of carbon, life as we know it is based on chirality. All life on Earth uses right-handed sugars and left-handed amino acids. You can see this in the way the DNA double helix always twists to the right. Molecular handedness is literally in your DNA. What's really cool is that these orientations were chosen at random, meaning there might be extraterrestrial life out there using the mirror images of molecules that we have here on Earth. Chirality is also a huge area of interest in pharmaceutical development. Enzymes in the body are highly specific to the substrate molecules they work on, meaning one enantiomer of a drug might be really effective while its mirror image is completely useless. Take ibuprofen, the active ingredient in some over-the-counter pain medications. The right-handed form reduces pain and inflammation, while the left-handed form has no effect at all. Chirality also has some more sinister implications. In the 1950s, a drug called thalidomide was marketed to pregnant women as a cure for morning sickness, and it worked. At least, at first. See, thalidomide was sold as a racemic mixture, or a 50-50 blend of the left-handed and right-handed forms of the drug. While the right-handed form did work to reduce nausea, the left-handed form actually caused children to be born with serious birth defects. As a result of the thalidomide tragedy, the FDA now requires researchers to study the effects of all enantiomers of any chiral drugs in development. It's amazing how something as seemingly insignificant as molecular handedness can have such profound impacts on human health. So next time you check yourself out in the mirror, remember that the world is actually made up of mirror image molecules, and one of them might just be the key to saving millions of lives.